For audio, there are two primary components. There's what's called the audio listener and an audio source. An audio source is a component which actually emits sound, and an audio listener is like the microphone in the world which picks up the sound. So first off, the audio listener is what we usually have attached to our camera, because that's usually where we want to perceive sound from, is in the same position as our camera. And so here in the scene, we have an FPS controller from the standard asset library prefab, and its child object is really just a camera attached to the character controller. And this game object is where we have our audio listener. It doesn't have any properties. And in fact, if you go look at the audio listener class, there's only two interesting things in here. These two static properties, pause and volume. Pause is a Boolean, which if you set to true, it effectively pauses all sound in the whole game. And volume is a float value between 0 to 1, where 1 is full volume and 0 is totally muted. So it's basically the master volume control of the whole game. So that's really all there is to know about audio listener. And in fact, you're really only supposed to have one enabled audio listener in your game at any time. You can have multiple audio listeners in your scene, like say if you have multiple different cameras and you switch between those cameras, just make sure to disable and enable the audio listeners appropriately so that there's only one active at a time. In fact, you'll get a warning in the Unity console if you have more than one enabled audio listener. I don't think anything actually bad happens if you have multiple audio listeners active at the same time, but it's not really a supported behavior of the engine, so you should avoid it. So we have our audio listener attached to our camera, and then in the scene I have on these two cubes, both of them have an audio source. And for this red cube, the audio source audio clip property is set to Prokofiev, and play on awake is checked. So this sound will start playing when the cube is loaded. So if I hit play here, you will hear the music coming out of this cube, and it gets louder as it gets closer because sound by default is spatialized. It's 3D position sound. And so it matters where the audio listener is relative to the audio source. The further away I get, the audio listener is getting further and further away, and so it attenuates. It gets quieter and quieter. And I get closer, and it gets louder and louder and louder. Also, if you have multi-channel output, stereo or 7.1 or something, if I turn to the left, it should only be coming out of your right channels. If I turn to the left, it should only be coming out of left channels. And yeah, also there's a Doppler effect you can kind of hear as I go back and forth. Maybe it's a little subtle at the... Yeah, actually not that subtle. Yeah, you get some pretty nasty pitch wavering as I move back and forth. Because the default Doppler effect is actually pretty strong. It's only on 1, but in my experience, that's a pretty strong Doppler effect. So something more realistic, in my opinion, would be something down like here. Here, I'll just actually exaggerate it so you can make sure you can hear it. Yeah, that's pretty noticeable. Yeah, and so for the attenuation by distance, the default setting is logarithmic roll-off, which is pretty natural. Now, this seems pretty sudden to me. In my experience, like it gets quite pretty damn fast in a way that's a little unrealistic to me. But you can also make it linear. So now it's a linear fall-off from distance, which is probably not realistic, but maybe that's what you want. And then you can also just make it totally custom. You can just set this curve to whatever the hell you want. You can do some weird stuff, which I don't know why you would want to do that, but you could. So actually, I'm gonna just stop this so it stops playing. There we go. You also have settings for looping. That's pretty obvious. It'll loop when it gets to the end. You can tell it to bypass effects. We'll talk about adding effects later. There's also a concept of reverb zones. They're like collider areas which you enter, and then it applies reverb effects to when the audio listener enters the reverb zone. It applies effects to anything that reaches the audio listener. Mute, pretty damn obvious. Output to mixer groups. We'll get to mixers in a minute. Priority, that's a number which determines that if you have a lot of sounds going, the hardware at some point is limited in how many sounds it can play. Is there some kind of upper limit for your system of how many sounds can be playing at once? Strangely, the lower numbers are higher priorities, so 0 is the highest priority, 256 is the lowest priority. And so you set priorities on your audio sources, and then sounds emitting from those audio sources with the higher priority will be privileged first. If we have to pick and choose which sounds are going to be playing, that's what priority is about. And then volume, that's of course self-explanatory. And pitch, that's also pretty self-explanatory. 1 is the normal pitch, but you can pitch stuff down. Here I'll lower the pitch to 0.7, 70% of normal. And now if we play, it's obviously lower and also slower as well. So it's not changing tempo to compensate. It actually slows it down and speeds it up when you change pitch. Okay, and then we have stereo pan. That's just biasing the sound between the two channels if it's a stereo sound. So this was actually a stereo source, I believe. Let me look. Was it? Yeah, it's a stereo source. So it should be controlling the balance between those two channels. And then spatial blend, this one's very important. This is determining whether the sound is positional or not. What they call 3D sound, they really just mean positional sound. And 2D, they mean non-positional. So if I set this all the way to 2D, turn off the spatialization entirely, then it's as if the sound is not coming from anywhere in particular. It's like it's right on top of the audio listener, no matter where the audio listener is positioned. So now if I play, and the sound's just coming from everywhere, no matter which way I face, no matter how far away I am, it's the same volume. Yeah, because it's not spatialized at all. And oh, I forgot to reset the pitch. But anyway, so that's what spatial blend does. And you can compromise. You can kind of go in between where it's partially spatialized. So the way to think of it is like 2D is actually really the default. It's just the sound playing with no effects added, with no attenuation or channel balance added. And the 3D is with the full spatialization, and then you can just have gradations in between. So let me set the pitch back to normal. And that pretty much covers it. Yeah, that's the core stuff in the audio source. And of course, all of this is accessible in script. You get a hold of the audio source component, and then in code, you have these properties. Clip is the audio clip, the piece of audio data associated with the sound source is playing as a Boolean. This is read only. You can't set it, but you can just read, is it playing? Volume and mute, those are just like this mute here and the volume slider here. That's what those are. Time and time samples, these are not accessible in the inspector. Time is a float property which gives you the playback position determined in seconds. And you can set this as well. So if you want to skip within the clip, you can do so with this property, and you do so by specifying the position in seconds. There's also time samples, which is specifying the playback position in terms of the PCM samples, the pulse code modulation samples. And this sometimes is useful because it's a more accurate way to skip within your clip. And then we have play and awake and loop. Those are just Booleans. They're just these checkboxes, loop and play and awake. We have spatial blend, roll-off mode, spread, max distance, min distance, Doppler level, pan, stereo, pitch. That's all these sliders we talked about. They're all accessible here in the inspector, but you can control them directly in code. And lastly, output audio mixer group. That is this property here, which concerns mixers. So what are mixers? Well, a mixer is a type of asset which we create inside Unity. Here I'll create an audio mixer. We'll just call it mixer 1. And the way I edit this here, double click, it brings up the audio mixer window. This is a window you can open up here, audio mixer. That's what it's showing you. And if I had multiple mixers, which I can have multiple mixer assets, they would all be listed here, and I could just swap between them. Here, I'll actually do that. I'll create another mixer. I can just duplicate this one, and hey, it's actually called mixer 2, just like I wanted. Yeah, so I'm going to swap back and forth between editing mixer 1 and mixer 2 in this audio mixer window. What the audio mixer contains is one or more groups, these mixer groups. And I create a group by hitting plus here, create a bunch of groups. I'll just call this, oh, where's the edit? There we go, group 1, and group 2, and group 3. Doesn't really matter. In a real project, you give these more logical names, but this will do for now. There we go. They were arranged as children of each other, but I didn't want that. I just want them to be directly children of master. So all the groups within a mixer are ultimately children of master. Master is always the root of the mixer, but then we can have like group 2 be a child of group 1 here. Yeah, there we go. Okay, so what these mixers are is that on our sound sources, let me go back to the scene. Red, I'm going to pick here group 1, and we'll say this gray cube also has a sound source. We'll pick group 3. Okay. Oops, don't want to bypass effects. Go back to the audio mixers. Okay, so now there are sounds being routed into these mixer groups, and we can apply various effects to everything coming in. So right now there's just the attenuation effect, which everything has. It's just a matter of controlling the volume. So this actually is a way to boost volume above normal. So here, actually, let me do that. I'm going to raise this all the way up. And now if we play the scene, it should be considerably louder. I hope it's not too loud. Yeah, that's pretty loud. Okay, so yeah, so everything fed into group 1 is having the effects of group 1 applied, and then the output of group 1 is fed into master. Whereas anything fed into group 2 is fed through then group 1, which is then fed through master. I should say routed. Sound sources are routed to the groups, and then the groups are routed. In this case, group 2 is routed to group 1, and all the groups are ultimately routed to the master group of the mixer. And then the output of the master group, that is what is actually ultimately picked up by the audio listener. Although actually what we can do is we can have one mixer feed into another. Right now I'm editing mixer 2 and it has these groups. I'm going to make mixer 1 a child of mixer 2, and it's asking me to pick a group within mixer 2. I'm going to say group 2. So now the output of the master of mixer 1 is being routed to group 2 of mixer 2. And I regret now not giving these clear names. Here, let me actually rename these. I'll call these group B, group A, and group C. There we go. So that's the basic idea. Audio sources route to groups of mixers. Mixer groups route into each other or into the master group, and the master group of a mixer can be routed into the group of another mixer. But any mixer where the master group is not routed to another group of some other mixer, the output of that master is picked up by audio listeners. And there are quite a few interesting effects we can apply to these groups, like say, for example, high pass, which cuts off frequencies below a certain hertz. Let's see, I'm going to cut off below 120, 130, whatever, close enough. And so if I go back to our scene, what's being routed to A? Was it, yeah, the red cubes. And now if we play, I don't know how perceivable that is. Let me go back to the audio mixer. Oh, edit and play mode. Yeah, there we go. You have to enable that. Otherwise, your live changes won't take effect, I believe. So let's turn this up. Well, that's definitely noticeable. Yeah, so this high pass filter is being applied to everything routed into group A. So that's one example of an effect applied through a mixer group. I won't go over these other things. They're quite standard stuff if you've done audio editing. So I'll let you investigate this stuff on your own. But I will note up here send and receive, which are not audio processing effects. The idea of a send is that when our mixer group gets a certain level of decibel input, it sends a signal to some receiver on another group, and that group can do something in response, like say duck its volume, which is a common thing where if you have output of one kind in your game, you want other stuff to get quieter or maybe increase. Usually you want other stuff to get quieter, like say when sound effects play, you want like the music to duck down, or when dialogue is playing, you want the music to duck down. So you can hook up these send and receive effects. And I won't go into the details here, but I'll just give you a heads up of what those things are about. And then over here, you'll notice these views. Views are simply just an editing convenience. If we had a really complicated mixer, you wouldn't necessarily want to look at all the groups at the same time. So if I create different views here, I'll just call it view 2 or whatever. It doesn't matter what this is called. For the individual views, I can toggle the visibility of the different groups. And so if I switch back and forth between the views, notice there's different selection of what's visible and what's not. So it's really just an editing thing. Whereas snapshots is a little more significant. The idea of a snapshot, here, let me get rid of the views here and make them all visible. The idea of a snapshot is if I have different snapshots, again, I'll just call the snapshot 2. I configure my groups in one snapshot and then do a different configuration in a different snapshot. Like say in this snapshot, the attenuation is set to -24, whereas in this snapshot it's +7. And so I have different snapshots, which programmatically in my code, when I access the mixer in my code, I can transition between the snapshots. So I set up different snapshots and then trigger transitions between them in my code. And the star here denotes that this is the start snapshot. I can make this one the start snapshot though if I right click and set as start snapshot. So now this is the state which the mixer starts out with. Last thing to cover about mixers is that when you access the mixer in code, you don't automatically have access to all of the properties of all the groups. In fact, you have access to nothing by default. if you want to programmatically control, say, the attenuation of group C here or the high pass of group A, you need to expose parameters. So here I click on group A, and if I want to expose this cutoff frequency so I can programmatically read and modify it in code, I right click and expose cutoff frequencies to script. And now as you see, there's a list of exposed parameters. There's a name, which by default is just my exposed param, but I can edit that so it has some other name. We'll just call it group A high pass. I don't know why it doesn't give it a better default name. That name was not very helpful. But anyway, so now there's this parameter called group A high pass, and now in my code when I access the mixer, there's a property for setting and getting the values of these exposed parameters. Let's see a very quick example of this in actual code. I have this audio demo script, and we want to access the audio mixer class, which is in the Unity Engine.audio namespace, which we have to import separate from the Unity Engine namespace. And so now I have this field of type audio mixer, which we just call the mixer. So in this game object where I have the instance of audio demo, we need to hook up the audio mixer. So I hit the select button and we wanted, I think mixer 2. Yeah, we want mixer 2. And so now when this audio demo script is instantiated, this property will be set to that mixer. And inside the start method, we can call getFloat and setFloat, specifying by string name the name of the exposed property we want to read and modify. So here getFloat is getting the value, the float value of that exposed property, group A mixer. We're logging it out, and then we're setting it to the value of what we read plus 100. And oops, I do not have that name here. What was the exposed parameter name? It was group A high pass. Yeah, right. Okay, so let me fix that real quick. High pass, group A high pass. There we go, that should work. And so now if we come back and play the game, we should see printed on console 1837, and it should have modified our mixer. I don't know if it shows up here, but it should have a different high pass value. Yeah, I think, yeah, it was 1837, now it's 1937. So that's how you read and modify the exposed parameters of your mixer. I'm going to get rid of all that. We don't actually want that business. Okay,